Welcome to Biodiversity and Conservation. So we are continuing the next part of it. Now the next part, ecologists and evolutionary biologists have proposed various hypotheses. Out of these hypotheses, we are selecting the three hypotheses here. The first one is speciation is generally a function of time. Unlike temperate regions, tropical latitudes have remained relatively undisturbed for millions of years and thus had a long evolutionary time for species diversification. So this is the first hypothesis given by the ecologist. Now what they say is speciation, meaning formation of a new species. Again, it is the part of evolution. We are going to study it in the part of the evolution. Speciation is nothing but formation of a new species. Homo sapiens is one species. From us, if a new species arises, we call the process as speciation. Okay. So speciation is generally a function of a time. Unlike temperate regions, temperate regions meaning cold countries, tropical latitudes have remained relatively undisturbed because in the tropical areas the climatic condition is even throughout the year. It is almost constant throughout the year. That's why the tropical latitudes have remained relatively undisturbed. That means they are not disturbed and hence species will be continuing in those regions. So for millions of years and thus had a long evolutionary time for species diversification. Because of this environmental condition, as the environmental condition is suitable for the sustenance and survival of the species, from a single species many species have been arised. This is what is called as diversification of the species, and different species have been formed. Okay, we call it as evolutionary tree also. Origin is one from which many species have been formed. So how the species have been formed? This is the part of study of evolution. So scientists believe in evolution, and remember today we believe in the evolution because this was given by a person who is called as a father of evolution, and his name is Charles Darwin. Okay. Now next one. Second point is tropical environments, unlike temperate ones, are less seasonal, relatively more constant and predictable. This we know. What is the statement or hypothesis means here? Tropical environments, the tropical region, that means equatorial belt, unlike temperate one is cold country, are less seasonal. That means tropical region almost it is warm throughout the year. Almost it is warm throughout the year. While in temperate, the temperature during summer season, highest it may reach up to 10 degrees Celsius only. Then after that, during the winter season, as well as the snowfall season, the temperature will be almost in minus degrees only. So that's why tropical environments have almost same temperature throughout the year. That's why we say relatively more constant and predictable. We know, we predict what we predict. This is the month of June. What we predict in the month of the June? Yes, it is the rainy season. Monsoon is going to arrive. So wait and watch. So you will be waiting for the rain. Rain will come. This is what is called as prediction. So we are predicting certainly will receive the rain. Okay. Then the third hypothesis. There is more solar energy available in the tropics. Yes, true. There is more solar energy available in the tropical regions, which contribute to higher productivity. This is most important. That's why productivity with respect to the plants. Plants are the producers, we are consumers. So plants will produce more food. When they will produce more food, if solar energy is there, okay, then what about in the tropical regions? Tropical regions, the number of the plants is less because they also receive the solar radiations, but the solar radiations which are received are less while compared to the plants which are present in the equatorial belt in the tropical regions. That's why productivity is highest in the tropical regions and it is less in the temperate regions, least in the polar regions, because plant should survive, so climatic conditions should suit it. So that's why tropical regions have they receive more solar radiations, and hence this tropical region, it consists of and it also helps in production of a higher productivity in the plants. Okay, so this is regarding the part of the hypothesis proposed by the evolutionary biologist. So this is regarding the first part of patterns of a gradient, and with this we'll move on to the next part. The second part is a species area relationship, and in that species area relationship, let's look at the species richness along with the area. So we are coming across the second one is a species area relationship. Species area relationship, this is the second part in the patterns of gradient. The first one is latitudinal gradient, second one is a species area relationship. Now this species area relationship, this was given by a person called as Alexander von Humboldt. It was given by Alexander von Humboldt. He is an ecologist, and this ecologist, he has given the species area relationship. What does it determines? So let's study with the help of a graph. In the graphical representation, here we have an area, this side we have the species richness, so this is the graph that shows a relationship between the species and area. Now in the species area relationship graph, this is the species richness, this is the area. Now here we find a rectangular hyperbola curve. Here we give an equation S equal to CA raised to Z. This is an equation which is given by Alexander von Humboldt, and if it is plotted on a log scale, so here it is also termed as a log scale, log scale. For this also we give an equation called as a log S equal to log C plus Z log A. This is on the log scale. Log S is equal to log C plus Z log A. Then what does this species area relationship shows? Now let us consider an area. Suppose if we take our locality, okay, let us take our college campus only. Our college campus is very small. If it is small, then the total number of species are also less because area is less. Okay, so species means it is animal species also, plant species also. Now if area is small, species number is small, then increase the area. Okay, let us take our entire taluka. Okay, then area is more, different species are there. Increase district, go to entire state, go to entire country. Okay, now country means it is very large, huge, lot many species will be there. Then extend it still, continent has the highest species. Now what we say is here with respect to area and species richness, as the area increases, species richness also increases. As the area increases, species richness also increases. As the area decreases, species richness also decreases, certainly. Okay, so increased area will increase the richness of the species. As a result, the graph will go straight. Then still extend the area, still the species richness will increase, and still extend the area, the species richness will remain constant. That means as the area increases, species richness also increases, but up to a certain limit. Remember this, up to a certain limit. That's why we get a rectangular hyperbola curve. What type of curve do we get in species area relationship? Rectangular hyperbola curve. Okay, and it is given with an equation S equal to CA raised to Z, and it is plotted on the log scale also, where we give an equation log S equal to log C plus Z log A. Then what are these? What is S, C, A and Z? Let's see this. S refers to species richness. Then C is a y-intercept. C is y-intercept, A is area, and Z is slope of line. Okay, so this Z is a slope of a line. This slope of line, it is also called as a regression coefficient. Okay, now this is regarding the species area relationship. Okay, now certain values are also there in normal areas. In normal areas, the Z line. Okay, in normal areas, the Z value will be around 0.1 to 0.2. Then in large areas, say about continents, let us say continent, it is a large area. Now in normal areas, when the Z value is small, in large area the Z value will be certainly high. It ranges from, the Z value lies from 0.6 to 1.2. Okay, that means if the Z value increases, this line becomes more steeper. Look at this, the rectangular hyperbola, it becomes more steeper. Okay, if the Z value increases, that means as the area increases, species richness will also increase. That's why what we say, it increases, but there is a limit for the species. Though we expand the area, it doesn't mean that the species will increase continuously. So there is a limit for it. Okay, so as the area increases, the species richness will also increase. Okay, so this Z value, so there is an numerical number which is given for the Z value in normal areas. Okay, normal areas means let us take our India as a country. So in this country, in normal areas, the Z value will be around 0.1 to 0.2, which is standardly given by ecologists. And in larger areas, the Z value is little bit higher. It is around 0.6 to 1.2. That means in normal areas, the Z line is a little bit less. The value of the Z is less, and in larger areas, the value of the Z is more. So this is regarding the species area relationship, which is given by Alexander von Humboldt. And with respect to the species area relationship, it is also given on a log scale, as we say log S equal to log C plus Z log A. Okay, if the values are given, we can calculate it. If we know the value of yes, species richness, then areas and Z line, we can calculate this part also. Okay, so this is regarding the part of species area relationship. Okay, let us study the Z line more in elaborate way. Now regarding the Z line lies in the range of 0.1 to 0.2, as we have studied, regardless of a taxonomic group, whether it is a plants in Britain, birds in California, or molluscans in New York State. That means the Z line, if it is 0.1 to 0.2, as we say in normal areas, the Z line is around 0.1 to 0.2. Okay, this is an estimated or calculated part by the ecologist only. The Z line will remain 0.1 to 0.2 in normal areas with respect to species. With respect to species means it does not mean to only one particular species. Now here we have given an example whether it is plant in Britain. So in the Britain we have different species of plants. The Z value lies in the range between 0.1 to 0.2. Or it might be birds in California. In the California we have bird species. The bird species Z value, it lies in between 0.1 to 0.2 only. Or molluscans in New York. Okay, molluscan shelled animals, we have different, like apple snail is there, octopus is there, so all belongs to molluscans. If you take these species, the species number, not a number, the species richness lies in the value of 0.1 to 0.2. Okay, this is one thing. Next, for larger areas, as we have taken continents here, this Z value, it ranges between 0.6 to 1.2. Just we are elaborating this part here. Okay, So a larger area, Z value increases. Normal area, normal means while compared to large, it is little bit less. If it is a continent, larger area, the Z value lies between 0.6 to 1.2. Okay, so remember these are most important. Okay, so these are most important points here, because the value of Z will be asked. So what is the value of Z in larger areas? What is the value of Z in smaller areas or normal areas? Okay, so it is a 0.1 to 0.2, and here it is a 0.6 to 1.2. This in larger areas. That means this rectangular hyperbola curve, it gets more steeper. More steeper means from this point it increases. Okay, it becomes steep. If the Z value increases, it becomes instead of rectangular hyperbola, it increases. So that's why the Z value decides what type of curve do we get. But generally we get a rectangular hyperbola curve. This curve is called as a rectangular hyperbola curve. Okay, next one. For frugivores, frugivores meaning fruit eating birds. For fruit eating birds and mammals in the tropical forest. So we are talking about the tropical forest, birds and mammals which feeds on the fruits of different continents. Look at this, the continent is changed. We have an Asia continent, Europe continent, then American continent. In this way of different continents, the slope is found to be 1.15, which is most important. What is the Z value for frugivorous birds? If this question is asked, the Z value for fruit eating birds is 1.15. So frugivorous meaning fruit eating, either it is bird or animal, we call them as a frugivorous animals. Okay, so frugivorous birds, frugivorous animals, the Z value is 1.15. So this is regarding the species area relationship, as this species area relationship was given by an ecologist called as Alexander von Humboldt. He has just shown that as the area increases, the species richness also increases, but it is not unlimited. There is a limit. That's why in the nature, nothing is unlimited. For everything, we have a limit. Okay, so that is what it states. So with this, let's end up today's class, and we'll continue with the more important and attractive aspects of biodiversity and conservation. Thank you.